Hey everyone, welcome back to Secure7, your trusted place to learn ethical hacking the right way. So far, we've explored the foundations of hacking and dug deep into networking basics. But now, it's time to get our hands dirty in the operating system where most hacking actually happens. Linux. Why Linux? Linux is the playground of hackers. Whether you're using Kali Linux, running tools like Nmap and Metasploit, or setting up a C2 server, it all happens inside a Linux environment. If you want to be a real ethical hacker, knowing Linux is non-negotiable. Not just how to use it, but how to navigate, control, script, and secure it. What you'll learn in this module. In Module 3, Linux Basics for Ethical Hackers, we'll cover how to use the Linux terminal like a pro, file system structure and key directories, essential commands every hacker must know, managing processes, permissions, and services, Bash scripting intro, yes, we'll touch scripting too, real-world examples from hacking labs. This isn't a boring Linux tutorial. This is Linux with a hacking mindset. You'll learn what you need to know as a penetration tester, not just a sysadmin. Goal of this module. By the end of this module, you'll be able to confidently navigate any Linux-based system, understand file structures, manipulate users and permissions, and lay the groundwork for automation and exploitation. Whether you're in a CTF, red teaming, or building your own tools, this knowledge gives you the edge. So let's jump right in. Coming up next is Section 3.1, Introduction to Linux and the Command Line. Don't forget to like, subscribe, and hit that bell icon so you don't miss future modules. This is Secure7, and you're learning to hack the right way. Welcome to Section 3.1, Introduction to Linux and the Command Line. Before you can hack effectively, you need to be comfortable in Linux. And more importantly, the command line is where most of the real magic happens. If Windows is the world of GUIs and clicking, Linux is the underground tunnel where real hackers operate. So let's start with the basics. No fluff, no filler, just what you actually need to become a hacker.
What is Linux?
Linux is a free and open source operating system based on Unix. It powers 90% of cloud servers, most hacking tools and distributions, like Kali, Parrot OS, Android phones, IoT devices, and even parts of space systems. When you're learning ethical hacking, Linux is your home turf. Why ethical hackers use Linux? Here's why most hackers and pen testers prefer Linux. It's lightweight and customizable. It comes with built-in networking tools. You have total control over the system. You can automate anything via Bash scripting. Almost all ethical hacking tools are made for Linux. Meet the terminal, aka shell. The terminal is a text-based interface that lets you interact with your OS directly. Think of it like a superpower. GUI is fine, but the shell gives you speed, precision, automation, complete system access. There are many shells like zsh, but we'll use Bash, the most common one. In Kali Linux, you'll use the terminal for scanning, scripting, privilege escalation, and so much more. Basic command line terms. Here's a quick glossary to make you feel less lost. Term, meaning, nhang. Shell, interface to communicate with OS. Bash. A type of shell stands for born-again shell. Command, instruction you type in the shell. Prompt, the dollar symbol that waits for your input. Terminal, the window where you type your commands. You don't need to memorize everything right now. Just get comfortable. Your first few commands. Let's try a few essential Linux commands you'll use almost daily. Bash pwd, print current working directory ls, list files and directories, cd, change directory mkdir test, create a new directory, touch file to create a new file, rmfile.txt, delete a file. Try these out in your Kali VM. Don't be afraid to break things. This is your lab. Hacker mindset tip. Don't treat Linux like Windows. Think like this. What can I control? What can I automate? What can I explore with the shell? The command line is your playground, your toolkit, and sometimes your weapon. Summary of this section. Today you learned what Linux is and why it's crucial for ethical hackers, the power of the command line interface, basic commands to navigate Linux. In the next section, we'll go deeper into Linux file system structure, so you know where everything lives and how to control it. Call to action. Try out the commands in your terminal. Drop a comment if you faced any errors. Like and subscribe if you're learning something new every day. This is Secure7, and you're learning to hack the right way. Welcome back to Secure7, and you're now in Section 3.2, Understanding the Linux File System Structure. If you want to navigate Linux like a hacker, you must understand its layout. You can't hack what you can't find. Let's look at how Linux organizes its files and directories, and why this is so important for ethical hackers. Why file structure matters for hackers. When you exploit a system, you usually gain shell access. Your next move? Navigate the file system. Escalate privileges, extract data, cover tracks. So knowing where files are stored, which ones are critical, and which directories are most juicy is key. Linux directory structure, the root tree. At the top of every Linux file system is the root directory, represented as / everything. Yes, everything starts from /. Here's a quick look at the core folders you'll see. Directory, what it contains. /bin. Essential user binaries like lscatcp. /boot. Bootloader files, kernel. /dev. Device files, USBs, drives, etc. Configuration files, for hackers. Home, user folders, e.g. home Kali. Lib, shared libraries used by programs. Media, removable devices, e.g. USB mounts. /opt, optional software installations. /proc, virtual info about running processes. /root, home directory of the root user. /bin, system binaries, admin commands. /tm, temporary files may contain session data. USR secondary hierarchy, apps, docs, libraries, logs, mail, databases, etc. /varlog, goldmine. Hacker hotspots. When you pop a shell on a target system, these are key locations to check. /eats /passwd and /etc/shadow, user credentials logs that may expose activity. /home /username, desktop, sensitive user files. TMP, temporary scripts or files being used. /root, access only with privilege escalation. Commands you need. Let's go over some essential commands to explore this structure. Bash cd /ets hack, go to the config directory, ls else home, list user home folders with details, cat /etc passwd, view user account information, find /name.conf, find config files, can be juicy, see disk usage per folder. Use these commands to discover, investigate, and understand any system you have access to. Pro tip. Avoid accidental destruction. Some directories are dangerous to modify unless you know what you're doing. Never run random delete commands as root. You might break your whole OS. Always practice in your Kali VM. Never on real production systems, unless authorized. Summary. In this section, you've learned the hierarchy of the Linux file system, what's inside common directories, which locations are most useful for hackers, how to navigate and investigate them using basic shell commands. In the next section, 3.3, we'll talk about file and directory permissions, because as a hacker, you need to know who owns what, who can access or modify what, and how to escalate if you're locked out. Try this exercise. In your Kali Linux VM, 1. Explore the /etc home / var directories. 2. Use ls/la, cat, and find commands. 3. Take note of anything that seems sensitive or interesting. Subscribe to Secure7, hit the bell icon, and drop out in the comments if you're ready to go deep into real hacker territory. This is Secure7, and you're learning to hack the right way. Welcome back to Secure7, and this is Module 3.3, Linux File and Directory Permissions. This is where things get real, because knowing who can do what on a system is the key to unlocking privilege escalation, persistence, and stealth. Let's dive in. Why permissions matter to hackers. Every file and folder in Linux has access control. It tells the system who can read, write, or execute it. If you don't understand these permissions, you'll either miss critical privilege escalation opportunities or break things and get caught. Let's break it down. The permission structure. Use this command to view permissions, bash ls-del. You'll see output like bash*xr1 user group 1234, jan 1st of 12 script.sh. Let's decode a wxrxr. First character, file type equals file, d equals directory. Next 3, owner permissions, Next three group permissions are X. Last three others, everyone else permissions. So in this case, owner can read, write, group can read and execute, others can only read. Hash permission types explained. Symbol, permission, applies to R, read, view content of files directories. W, write, modify files or create delete in directories. X, execute, run a file or enter a directory, changing permissions. Use these commands. chmod, change permissions. chown, change owner. charp, change group. Examples: bash chmod plus xfile.sa add execute permission. cmod 755, script.shaf rwxrxrx, chown root file, change ownership. Hacker perspective, what to look for. Here's what should raise your eyebrows when you're hacking a system. Files or scripts with 777 permissions. Misconfigured sudo rights. Writable files in system directories. Sensitive config files readable by non-root users. Cron jobs owned by root but editable by users. Backup files in /home or /tmp with loose perms. Example, if a script in /sys cron.d/ is writable by any user, you could modify it to run a reverse shell as root. suid sgid sticky bits. These are special permissions that get interesting. suid chmod 4755 runs as the owner, not user. sgid inherits group. Sticky bit restricts file deletion in shared dirs like /tmp. Check for them, bash find /perm-4002 dev null. If you find suid binaries owned by root, test them. They might let you escalate privileges. Try this now. In Kali or your lab. 1. Create a test file. 2. Run chmod chown lsl. 3. Try to execute as different users. 4. Search for SUI file. Summary. You've now learned how Linux permissions work, how to read and change them, which ones matter most for hackers, what suid sge and sticky bits do, how misconfigured permissions lead to privilege escalation. Coming up next, in Module 3.4, we'll explore basic shell commands every hacker must know, so you can take full control once inside a system. Subscribe to Secure7, comment if you've ever used SUID to escalate in a lab, and don't forget to try all these commands in your own hacking environment. You're on your way to becoming a professional ethical hacker the right way. Welcome back to Secure7. In Module 3.4, we're diving into the essential Linux commands every ethical hacker must know. These commands are your tool belt once you've gained access to a Linux machine, whether through SSH, reverse shell, or physical access. The faster you move and the more you know, the more power you have inside the system. Let's get hacking. Section 1. Getting oriented inside the system. pwd. Print current working directory bash pwd. ls, ls-l, ls-a. List files and directories. Bash ls-l cd. Change directory bash cd/etc. Clears the terminal. womi tells you the current user. Hostname, ID, unamha. System information. Tip: after getting a shell, always run womi and ID. You need to know your privileges before moving. Section 2. File and directory management. Cat less more. View file contents. cpmv rm. Copy, move, remove files. mkdir rmdir. Make, remove directories. Touch. Create new empty files. Bash cats passwd cpfile.txt/temp rm-rf/temp/test. Find, locate, find files. Bash find /name config php to dev null. Section 3. Useful for recon and exploitation. psaux. See all running processes. Top or htop. Real-time system monitor. netstat tolmp ss. See network ports and processes. ifconfig or IPA. See IP addresses. ARP, ping, tracer route, network tools. Cron tab-l. List scheduled tasks. Red team tip. Cron jobs, open ports, and exposed services are gold mines for attackers. Section 4. Permission and ownership commands. chmod, chown, ls-l, we already covered in 3.3. Sudo, su, elevate privileges if allowed. Groups. See group memberships bash sudo ll. This command tells you what you can run as root, a critical privilege escalation check. Section 5. Log files and cleanup. History shows command history, bash a history, clear history, /varlog syslog, /varlogs auth.log, wipe logs, only in CTFs. Note, in the real world, log tampering is illegal. In labs or CTFs, it's fun. In real life, it's a crime. Pro tips for efficiency. Use tab for autocomplete. Use dan to chain commands, up-down arrows for command history, alias commands to shorten repetitive tasks, man for manual pages. Bash man ls. Recap. You must master these. Navigation, cd, ls, pwd. File ops, cat, cp, rm, find. Recon, ps, netstat, ifconfig, sudo-l. Privilege, chmod, chown, groups. Logs and cleanup. Histories, var/log/. If you can't move quickly in a Linux shell, you'll struggle during exploitation or post-exploitation. So practice these commands daily. In Module 3.5, we'll cover user and group management in Linux, because users are always the weakest link in any system. Comment below. What's your favorite Linux command as a hacker? And if you're learning something valuable, smash that subscribe button and share Secure7 with your friends. Welcome back to Secure7, where future ethical hackers are forged. In this lesson, Module 3.5, we'll explore how users and groups are managed in Linux, a vital skill during privilege escalation and post-exploitation. Whether you're doing a red team engagement or just managing a secure Linux server, understanding how users and groups work is non-negotiable. Section 1. Understanding users and groups. In Linux, everything is user-based. Even services run as specific users. So here's what you need to know. Each user has a username, a unique UID, a home directory, a default shell. Groups are collections of users that share permissions. Pro tip, attackers often pivot through user accounts to elevate privileges. Section 2, key files to know. /etc/passwd stores user account info, non-sensitive. /shladow stores hashed passwords, only accessible to root. /group lists all groups and their members. Bash cat etc pasty cat /etc tag group. Use these to enumerate users and privileges on compromised systems. Section 3. Managing users. Add a user, bash sudo add user John Doe. Delete a user, bash sudo deloser John Doe. Change user info, bash sudo usermod-ag sudo John Doe. Lock unlock users. Bash sudo passwd-l John Doe lock sudo passwd John Doe unlock. Locking accounts is useful for preventing unauthorized access without deleting the user. Section 4. Managing groups. Add a group, bash sudo group add hackers. Add user to group, bash sudo usermod-ag hackers John Doe. See group memberships, bash groups change group ownership of a file, bash chgrp hackers file.txt. Hacker tip. Always check for users in privileged groups like sudo, admin, docker, etc. Section 5. Enumeration tactics for hackers. When you're inside a Linux machine, check for users with UID 0, root level access. Look for misconfigured sudo rights, bash sudo-l. Check cron jobs run by other users, potential privilege escalation. Explore SUID binaries owned by non-root users. CTF secret. Enumerating user and group configs often reveals weak spots for lateral movement. Recap what you've learned. Users equals identity, groups permission bundles. Key files /passwd/se/shadow et/group. Adding, removing, locking, and modifying users. Group management and ownership. How hackers exploit user configurations. Mastering user and group management helps you understand system structure, detect weaknesses, and avoid security misconfigurations. What's next? In Module 3.6, we'll wrap up with essential shell scripting basics, because automation is a hacker's best friend. If you're enjoying the series, comment below. I control the users, I control the system. And of course, don't forget to subscribe to Secure7 and hit that bell icon so you don't miss Module 3.6. Welcome back to Secure7, your training ground for mastering ethical hacking. In Module 3.6, we're diving into something powerful, shell scripting. Why learn scripting as a hacker? Because automation is the secret weapon of every successful cybersecurity pro. Why shell scripting matters in hacking? Shell scripts allow you to automate reconnaissance, enumeration, and exploitation, customize payloads, scan networks, or even brute force login portals. Save time and avoid repeating manual commands. Shell scripting, more hacks in less time. Ethically, of course. Section 1. What is a shell script? A shell script is a plain text file that contains a series of commands to be executed by the shell. Default shell in Linux, bash/bin bash, file extension .sh. Example, bash*/bin bash echo welcome to Secure7. The first line is the shebang, telling the system what interpreter to use. Section 2, your first script. Let's write a script that checks if a website is online. bash-bin/echo checking website status. Read-p enter URL. URL ping -c2 URL after F0. Then echo URL is reachable, else echo URL is down. Fi. To run it, bash chmod +x checksite.h/checksite.h holds the exit status of the last command. 0 means success. Section 3, loops and conditionals. For loop, useful in scanning, bash for IP and un5 do ping-c1192.18.1 IP done if-else statement. Bash if 9ff/et pass wd, then echo user file exists, else echo file missing. Fi. While loop bash count equals 1, while count-5 do echo attempt $count, count++ done. Section 4, real-world ethical hacking uses. Recon automation. Create scripts to run nmap scans on a target list. Vulnerability testing. Automate Nikto, GoBuster, etc. Brute force attempts. Custom password loops. For CTFs only. Cleanup tools. Remove payloads or evidence post-testing. Example, auto nmap scan, bash/bin bash for IP, do nmap nikes s t4 IP, scan results.txt done. Section 5, best practices for hackers using scripts. Test scripts in a schlab environment only. Always sanitize user input to avoid injection vulnerabilities. Reuse functions and modularize your code. Document your scripts. You'll thank yourself later. Summary. Shell scripting lets you automate hacking tasks. Learn how to write and run basic scripts. Use loops and conditions to make your scripts dynamic. Apply scripting to recon, scanning, brute force, and more. Practice with real-world tools in your Kali Linux lab. What's next? Module 3 is now complete. You've mastered the Linux fundamentals every hacker should know. In Module 4, we step into the scanning and enumeration phase, the first act of real ethical hacking. Action time. Drop a comment, scripts superpowers. And if you're finding value in this course, hit that subscribe and turn on the bell icon. This is Secure7, and you're on your way to hacking the right way.